Hello and welcome to another video from sickmaths.co.uk, where you can find the whole of GCSE Maths explained on video, all for free, and other things like some super revision guides. Do check it out. This video is about simultaneous equations. Okay, we're going to use a method called the elimination method, because you add or take away the two equations from each other, and then what happens is something is eliminated. One of the letters are eliminated, and then you get an easier equation to solve and stuff like that. So let's just see what I'm talking about here. So you got 3x plus y equals 17, and you got x plus y is 3. Now if I've labelled them equation 1 and 2, by the way, which is useful, you'll see in a second. But what I'm also doing is taking them away from each other. Okay, that's what the takeaway over there is for. So it means I'm going to do 3x take away x is 2x, y take away y, nothing, it's been eliminated, and 17 take away 3 is 14. So you got 2x equals 14, and then you can say x equals 7. Yeah, so basically you made it really easy for yourself. And then once you know x is 7, you can say, well, I know x is 7, so 7 plus what makes 3? 7 plus 4, 7 minus 4 equals 3, so y must be minus 4. The way I've written it down is substitute x equals 7 into equation 2. Okay, so I put 7 into this equation, I replace the x with a 7, and then I managed to get this equation. 7 plus y is 3, rearrange, and y equals minus 4. So now you can see why I bothered labelling the equation, because it was useful here. Now you might be wondering, how can you just do that? Just take the equations from each other? That's a bit crazy, isn't it? Well, think about it like this. If you got this stuff, this 3x plus y is 17, okay, and this x plus y is 3, right? Now, if I do this stuff, take away this, the answer to that should be the same as this take away this, right? Because, you know, they're the same thing as each other. So this take away this should be the same as this take away this, because this is equal to that and that's equal to that. Yeah. So that's the idea. Anyway, so 3x plus y take away x plus y. How do you do that? Well, you take the x's from each other, you take the y's from each other. Okay, and so that's the basic principle behind it. You can do the same thing here, except for this time I'm going to use an add. And when do I use add? Well, these things are opposite, the 2m and the minus 2m. So if I add them together, it's 2m plus minus 2m, which is nothing. Yeah, adding a positive and a negative together, which are exactly opposite, makes 0. And so now you've got 5n plus n is 6n, 2m plus minus 2m is nothing, eliminated. Okay, and 16 plus minus 4 is 12. So 6n is equal to 12, therefore n equals 2. Okay, so hopefully you know how to add positive and negative numbers. If you don't, just go to, you know, the negative numbers video. Just try to search negative, okay, in sickmaths.co.uk, and then that will be explained if you got confused about adding 2m and minus 2m together. Anyway, once you know n equals 2, you can substitute n equals 2 into any of these equations, or substitute into equation 1, just because, although that's actually easier, I just want to show you that you don't have to substitute in equation 2, you know, all these silly things. Anyway, so I substitute into this equation. I've got 5 times 2 is 10, plus 2m is 16, yeah, because n is 2 now, so it becomes 5 times 2. So you got 10 plus 2m equals 16, like I just substituted it there, and yeah. What was I saying? Yeah, so 2m equals 6, and then m equals 3, blah blah. Now it's getting a little bit harder. Example C, I've got these two equations, label them as usual, equation 1 and 2. Now I'm going to take equation 1 and I'm going to double it. Okay, so I'm going to double, this is another thing you can do. If you double each of these, the overall answer is going to be doubled as well. So what happens is, you double that, gives you minus 2b, double that, gives you 2a, double that, gives you 10. And that I call equation 3 now. Okay, and why did I bother doing that? Because if I add or take away these equations right now, nothing would be eliminated. Okay, because nothing is exactly the same or exactly opposite. No, 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 it's not. So, minus 2b plus 2a equals 10. I've put that underneath here, and you'll see why, because, okay, can you see these are exactly the same? They're both minus 2b's. So this stuff, take away this stuff, is going to be nothing. So that's what I've done, take away. So you take away when you've got exactly the same thing, and you add when you've got exactly the opposite. Okay, so I've got exactly the same thing now. Okay, that was part of the plan. I thought, oh, if I double that, I could make it look like that. I could have trebled this top one and then made the A's the same, but it's easier to just title rather than times by 3. You get smaller numbers, I should say. It's not easier, but you get smaller numbers, which is good. Anyway, so, and I purposely put the 2a. I could have put this equation on top of that equation, then I would have got 2a minus 3a, but I like it like this. I like 3a take away 2a. It's better that way. So, which just gives you a at the end. That take away that is nothing. 21 take away 10 is 11. So a is 11 because that was what was left. Now, once I know a is 11, substitute a is 11 into equation 1. Okay, I'm not going to really. I'm not going to substitute into equation 3 because that's longer than it needs to be. Yeah, this is the short version of this, isn't it? So let's use equation 1. It's the shortest one. So I got minus b, and a is now worked out to be 11. So minus b plus 11 is 5. Okay, and then rearranging gives you b is 6. Okay, just solve that very simple equation there. I'm going to move on. Equation example D. You got these two equations. I can't actually double any of them to make the other one. I can't double or treble or whatever this to make that. I can't times this by anything to make that, or vice versa. So what I have to do is I have to change both equations. So I'm going to take equation 2 and I'm going to times it by 5, so I'll get 10y's there, and blah blah blah. I'm trying to make the y's the same, and if I times equation 1 by 2, I get 10y as well. That's my plan. So basically, I want the y's to be the same, so I'm going to times this equation by 5 to make that 10y, and I'll multiply this equation by 2 to make that 10y, and then we're going to be on our way to finishing it. So if I multiply equation 2 by 5, that's going to give me 15x plus 10y equals 10, as it says there, times that one by 2 gives you 4x plus 10y equals 10, like it says here. Now take the equations away from each other. That will take away that is 11x, 15x take away 4x is 11x, 10y take away 10y, nothing, equals 10 take away 10 is nothing, so 11x equals 0, x equals 0, therefore substitute x equals 0 into equation 2, so that's 3 times 0 plus 2y equals 2. So 0 plus 2y equals 2, therefore 2y is equal to 2, therefore y is equal to 1. And we are done.